let's write linear equations in slope-intercept form from a table. So slope-intercept form is y equals mx plus b. Remember, m is the slope, and b is the y-intercept, okay? So for each table, you're going to be looking for m and b, okay? So m is the slope, that's the change in y over change in x. Notice on these horizontal tables, y is on the bottom. So if we look here, we can do any 2 points, but I'm gonna pick here because I'm sorry, that should be a change in x right there, shouldn't it? Because I've written too close to the table. So to change from 4 to 5, that's my y, I add 1, and to change from 0 to 1, I add 1. So my change in y is 1, my change in x is 1, 1 over 1 is 1. So the slope of this line is 1. Remember, b is the y-intercept. The y-intercept has an x-coordinate of 0. So you look for the point that has an x-coordinate of 0. So I see it right here. It is 0, 4. So b is 4. So I can write this equation as y equals 1x plus 4. You won't typically see the 1 in front of the x, but remember a coefficient of 1 is usually invisible, so it's y equals x plus 4. Okay, so this is a similar problem. We are going to find the equation of this line from context, but it's still from a table. The table below shows the linear relationship between the number of visits and the total cost. Write an equation in slope-intercept form to show the total cost, y, after x visits. So just like always, we need our slope and we need our y-intercept. Okay, so the slope, I'm going to find my change in y over my change in x. Remember that even though this is in context, number of visits, and total cost, when you have a sideways table, the top row is your x coordinates and the bottom row is your y coordinates, okay? So the change in y would be 30 to 42, that's plus 12. The change in x from 0 to 1 is 1, so 12 over 1 is 12. So it is costing $12 per person. B, remember you look for an x-coordinate of 0 to find your y-intercept. I see it right there, so B is 30. So y equals mx plus b. I get y equals 12x plus 30.